welcome to our webinar on the 3.7 roadmap. So we released 3.7 early this year, so basically first days of January. And since then, we're very heavily working already on 3.7. So it's really about time that we share with you, our community, what's in there. And as mentioned in the invite, we are really also looking for your feedback, what kind of features you're looking at, or what features you're missing. So kind of the TLDR, the short version of this entire webinar. What is in 3.7? So we got satellite graphs. We got a number of graph performance improvements. So especially if you run graphs at scale, if you want to do large traversals, this is going to be your release. We have a number of cluster and failover performance improvements. So if you're running in a large cluster and you have, for example, in Kubernetes, there are pods being rescheduled, nodes failing over, we're really working heavily on making that faster and more resilient so that basically it works more smoothly in larger and especially more dynamic environments where you might not be certain that a node will stay around forever as it used to be like in the traditional database world. We have optional schema validation for documents. So basically, you can specify a JSON schema, and we can optionally validate your documents against that schema definition, which is very helpful if you have a restricted schema. So for example, whenever I coded some demos, I often had the issue, I just mistyped something, which would have easily been caught by schema validation. We have a number of security improvements, so especially for like enterprise, when you want to do rotations and other things, key rotations, JWT token or TLS certificate rotation. This is going to be in 3.7. We added more metrics and other operability enhancements to also make it easier just to operate and also alert on issues before they appear. So in 3.6, we kind of introduced the new metrics endpoint, where you can just traditionally connect your Grafana or whatever else you want to use for viewing and measuring your metrics. And here we added a number of metrics, especially around cluster performance. So you can actually see what's holding up your cluster much more easily. We have Arango Search, which is the kind of full text retrieval engine inside ArangoDB. We added a lot of features for better support of fuzzy search. So if you want like regex or something in that direction, this is going to be really useful. And if you're running data center to data center replications, basically if you have this asynchronous setup, to fail over to a different data center if your primary data center is on fire or something else, we have improved the replication format here. What we are kind of dropping out, and I'll talk a little bit about the rationale later here, is the deprecation of the MMFiles, the memory map file storage engine. But if you've kind of closely followed the past releases, most features, for example, hot backup, they weren't supported by the MMFile storage engine anyhow. So basically all customers we talk to, most users we talk to in the community, this won't be a too big issue, but feel free to raise something in the chat, or we'll also have a separate blog post following up on that later. And so this is basically the TLDR of this webinar. For those of you who don't know me, I'm the head of engineering here at ArangoDB. Prior to that, I worked at Suki on machine learning and healthcare, Mesosphere, now D2IQ on kind of the container ecosystem, at SAP again on databases, and also kind of my PhD was in distributed database systems. So I've always been switching back and forth between those container worlds and the database world. ArangoDB, if there's someone who doesn't know ArangoDB, just the short kind of rundown. So it's a multi-model database, and we'll explore the idea behind native multi-model in just a second. We got open source community editions and enterprise editions with certain features which are limited there. mostly features required when you really run at scale. So our goal is always to really have a functioning open source community version, and a lot of people are also enjoying that. It's actually been around for a while. So the 1.0 release was in 2012. We currently have 60 employees working around that, of which roughly half are engineers really working on ArangoDB itself or the ecosystem around. And we got kind of like a split headquarters. So we're based in San Francisco, but most people are actually still here in Cologne, Germany, where I'm also right now. As mentioned, the idea of multi-model. So if you're an ArangoDB user, this is probably very familiar to you. But the idea is that with this entire NoSQL movement, there are graph databases, there are document databases, there are key value databases. But in also my experience, having built a lot of infrastructure, it's most often the case that one of those data models isn't sufficient. And then I end up taking like one database, I build the next database next to it. And so I actually then have to rebuild like a connection layer on top, merging the results from different databases. And so this was kind of the key idea behind ArangoDB, to have all of this in one database engine, where first of all, I don't have to worry about managing multiple databases. Also from a query performance, as it's all running inside one database engine, this of course also gives a number of performance improvements. It's distributed, so for example, also graphs can span multiple nodes, and it has a SQL-like query language, and also supports asset transaction, including multi-collection transactions, at least if you're on a single node, or this new cool feature called OneShard deployment. So as mentioned already, the community, and that's all of you here actually, is really growing, and this is always really cool, especially for me to see, as I've been like an open source person forever. I've worked on a number of open source projects, so it's really cool to see the uptake also, for example, here in GitHub stars, if we just want to see it as like one metric, where we are really growing. If you see like in kind of percentage growth, we're equal with Kubernetes, which is pretty cool in my opinion. A short commercial break, advertisement for another webinar following tomorrow, but it's just one slide. So we have this kind of like use case on top of ArangoDB, where a lot of people actually use it to store metadata for their machine learning pipelines. And we just released ArangoML Pipeline Cloud, which is kind of like our managed service for this, running on our managed ArangoDB service Oasis. So there we're going to have another webinar tomorrow if you're interested in that. But let's actually dive into and go back to ArangoDB. Before we start off with the 3.7 features, let's briefly talk about what we just released earlier. It's just slightly more than a month ago, so like 5 weeks ago, 3.6. So in 3.6, we had some cool features around OneShard Database scalability. So this is basically a performance improvement when you're kind of sure that your entire data set fits on one node, but you still want the replication for fault tolerance. And I have one slide on that coming up. We have the theme of observability and operability. So we have the so-called inspector, which allows us to more easily capture logs, metrics, bug reports. So kind of like an easy way to get a state of your cluster, especially if you're running in a cluster environment. That was actually, truth to be told, for 3.61. So that wasn't in 3.60, but was in the recently released 3.61. And we added this earlier mentioned metrics endpoint, which allows you to connect your Prometheus, Grafana, or whatever metrics solution you want to use, and in kind of like a cloud-native way, grab all the metrics in your cluster. And this is also where we're still adding new metrics in 3.7. We had a number of search improvements, so also some leading up to this fuzzy search, which is a theme in 3.7, but also around like document materialization, so leading to large performance improvements. And also in general, we had a number of performance improvements, especially around subquery optimization. So if you're using subqueries, 3.6 is already doing a lot, and we're going to add more, even more optimizations in 3.7. And also parallel AQL, where we improved the way in which queries can be split across different servers. But we'll see that in a second. And also around, if you're using hot backup, we had a number of improvements in 3.6 over 3.7. OneShard Database, as mentioned, that was kind of like one of the key features. And that was we observed that a lot of customers, they want a distributed database, but there are kind of two cases why you want a distributed database. On the one hand, it might be that your data doesn't fit on a single node, so you actually need to distribute or shard the data across multiple nodes. But on the other hand, your data might actually fit on a single node, but you need it to be distributed to be fault tolerant if a single node fails. And so OneShard, as the name says, is if all your data fits into one shard. And in that case, we now have optimizations from the query planning and also query execution that you get basically single server performance. So as the query optimizer knows all the data is on this one node, it can execute the entire query on one node. You get the same asset transactions you would get from running on a single node, but you're still failover safe because it's synchronously replicated to other nodes in the background. So I think this is a cool performance optimization for a lot of use cases where data actually fits on a single node. For scalability, observability, and operability. So in 3.6, we did a lot of work around being able to scale to larger clusters and also to operate those larger clusters. So as already mentioned, we have this inspector, which allows for server-side collection of setup and status, and also that across different deployments. So it also makes, honestly, our job easier because we can get structured debug information. And also if you're, for example, in the community raising an issue, I would highly recommend to just kind of output the inspector outtake. You can look through. We're not capturing any sensitive data or not anything of your data, but basically just a cluster setup. And then on the other hand, metrics hopefully help you by providing a structured statistics API, and we have some default dashboards around that. I think the alerting recommendations are not yet merged to docs, but let me check up on that. But basically, also with those default dashboards, we are also having some recommendations. And hey, if this goes above a certain threshold, you should actually talk to us or raise an issue in the community because your cluster is actually at risk. From the performance optimizations, so the subquery optimization, often if we kind of develop our queries, we do that in a kind of like iterative fashion. We start out with like the inner query, and once we're happy with that, we actually add like an outer query around that. And so step by step develop our query, which also makes it more readable. And in 3.6, we added a lot on optimizing the query plan around it, so basically merging all of that together and having a lot more cases where we can now optimize for subqueries being not slowing down the overall query. The second is parallel AQL, and this is actually just stage one, where we do a lot more for executing in parallel across different servers. So if your query is hitting different servers, we basically going to talk to all of them in parallel in many more cases now, and hence can get results much faster. In 3.7, we're also working on making that parallel to single node. All right, and this actually leads up to 3.7 features or the 3.7 roadmap, because this is always subject to change in, I think, all open source communities and also enterprise projects I've worked at. But currently, as said, we're pretty much like in the middle of the development cycle, and currently this is looking pretty good. But also feel free to provide feedback on what you're missing or what is the key feature you feel like we should really have in there for you to get benefit out of 3.7. So this is kind of the overview of what's happening in 3.7. So as you can see, kind of the big themes around 3.7 are going to be graph and cluster performance, as mentioned earlier, schema validation, security, and then following up again with more metrics and Arango search. And if you're running in large environments, also the improved data center to data center replication is going to be very helpful. We currently are aiming for end of April, which, if you're curious from an engineering perspective, that means for us, we try to finish, kind of have a code freeze end of March, and then QA gets 1 month to actually rip everything apart. I have that in some more detail on one of my last slides here, but we also want to involve you more into kind of this entire development process. So our current goal is to release in the middle of each month a test version, an alpha version, or whatever you want to call that, also with a description which features you can already test. So for example, right now, we're just finishing up the first alpha release to be pushed out to the community. And there you can, for example, already experiment with faster move shards and other optimizations which are already in there. Some of the key rotation is also already in there. So I think this will also give you the chance to, first of all, test it out in your environment, and hopefully also give us a chance to get earlier feedback on what's working for you and what might not work for you in certain environments. All right, so let's talk a little bit, let's dive a little bit into, and especially like satellite graphs, because I really believe this is a cool feature. As mentioned earlier, ArangoDB is a distributed database, and unfortunately, joins in distributed environments, they can become really expensive because we might end up with network traffic, and then the coordinator kind of has to fetch all data from different nodes and push it all together. And also, if you looked at, for example, OneShard, this is basically also a way to remove network traffic. So this is a common theme you'll see around like all distributed databases. How can I minimize network traffic and network latency, because this will slow down my query considerably. And we already have an optimization for so-called satellite collections. And the idea of satellite collections up here is that if you want to join certain documents, which are small, imagine you have like a very small description, which you want to join with like a large number of, for example, order entries. So your kind of like your customer base or your keys, they are very small, it's a small collection, but then you have like a lot of orders which need to be charted across multiple servers. And the idea of satellite collections is that we replicate the small data set across all servers. So hopefully this is a data set which doesn't get updated too often, but then we can actually execute all those joins like on a single node. We don't need this network traffic in between because we have a certain set replicated. And in 3.7, we are pretty much doing the same thing with graphs. So if you have like part of your graph or your graph which is small, but might actually reference a lot of documents, for example, we now have the option of automatically replicating that graph across multiple nodes, and hence your traversals can also all be on a single node. So to just understand that in more technical detail, let's look at like a default, or also worst case, this is kind of the worst case graph traversal. So we basically have data on multiple nodes. So both the graph is kind of distributed and also the documents. So we actually have to perform the traversal on all nodes, merge basically everything on the coordinator side. So this will incur a lot of network traffic, and also a lot of data needs to be shipped across the cluster. So if we do the same traversal with the satellite graph, and here you can already see kind of the graph itself often is a very small entity, so we can easily replicate that across all nodes. And so basically now we can do all those traversals on a local node. So we can do one traversal on DB server 1, we can do another one on DB server 2, another one here, and then we just have to fetch all those results and just join them. But we don't have to process the actual traversal on the coordinator or in a remote fashion. We just have to merge all the sub-results coming from each of the nodes or each of the charts. And so, for example, this is very useful if you have a small graph and a lot of document data. So, for example, you're measuring seismic sensors, and each of those seismic sensors is actually producing huge amounts of collected data. So that doesn't fit on a single node, so this really needs to be in a distributed fashion. But the metadata of the sensor, so kind of like the sensor description of the sensor ID, like which sensor, in which city is it, which region is it in, which country, which continent, so the entire metadata describing that sensor, that's actually rather small and in a graph fashion. And now we have an example query where we want to find all the earthquakes in California or in San Francisco. I still remember waking up after moving there, and the first times it was really confusing. Why did I just wake up in the middle of the night? And so basically what we have to do, we have to find all these sensors which are based in California. And this is a graph traversal. And traditionally, if we just go back here to our initial case, we would do the graph traversal like one node and then actually query out and distribute that across all other nodes. With OneShard, we can do, as the graph is on all nodes, remember it's rather small, we're going to do this traversal on all nodes in parallel, and then we can fetch all the results which are relevant to California here and ship them back to the coordinator, who then has to just concatenate and join them. Schema validation. I think a core feature of document databases, why a lot of people are using that, is actually schema-less. I don't have to define a schema up front. I can change it on the fly and also extend it on the fly. But sometimes there are actually use cases where I would like to have a well-defined schema. And so in 3.7, we are adding the JSON schema support. Actually, it might already be that it's in that test release we're going to launch this week, because it's also almost done from a development perspective. But I would actually have to check up on that, whether it has made it into that build or not. But it will be, if not in that build, the following alpha build or nightly build we provide for you guys to test. And so it allows me to specify almost the entire JSON schema functionality. We disallow references, but I think this is also, if we're talking about databases, this is not too useful most of the time. And as mentioned, this is optional. So if you want to stay with schemaless docs or only apply it to certain parts, only get an error, a warning if some of your docs don't match that schema, that's also fine. That's all up to you to define that. Performance. So we're still, as mentioned, those two themes, graph and kind of cluster performance. So we're working on parallel traversal for graph. So if you're starting, imagine you're fetching a set of start nodes, and then you want to start from them a number of traversals in parallel. So this can then all run in parallel in many cases at least. And we have a number of further graph optimizations. So for example, if you're not touching up on your vertex collection, if you're only caring about following a certain edge, but not having to look up data on the vertices itself, that will become faster. And in terms of cluster performance, we already have a faster movement of shards. And this is, for example, imagine you're running on Kubernetes, you want to change your leader, you want to circle through nodes because you're upgrading. This will be much faster, as we're doing a lot of that in parallel. Also related is just the in-sync performance, how we can check that one node is in sync with another. So imagine a new node joining, it first has to get in sync with the current leader. This will be, the shipping of data will be much faster thanks to the faster moving of shards. And then we also have faster checks to actually check and validate that we are in sync between multiple nodes. And we also keep on working on the further subquery optimizations to allow that what we started in 3.6 for more subquery use cases. And furthermore, we also have better support or even improved support for parallel AQL. Security. If you're running in large clusters, this is like rotation of any secret material is probably a big topic for you. So we allow you to rotate the actual encryption key by which data is encrypted on disk. Let me say that in quotation marks, because what we'll do for performance reasons is the disk encryption is going to stay the same, but there's going to, the secret key by which the actual on-disk representation is encoded can be encrypted by a user-defined key, and that can be rotated. Then we have a JWT token rotation. So for super user access, imagine your sysadmin is leaving the company. You want to rotate the tokens, which he might have stored somewhere, to really make sure he doesn't have access. And then last but not least, TLS certificate rotation for safely talking to ArangoDB. As I think I also had that on the first slide, we're also deprecating one of the storage engines. So if you're relatively new to ArangoDB, you might not actually ever have noticed that you have a choice of storage engines. So storage engine is kind of like the part of a database which cares about how is it written to disk, how does it perform. And in the past, you had two choices in ArangoDB. And that was MMFiles, which was the initial version when we first brought out ArangoDB. And since then, it has been replaced by RocksDB, since a number of versions also as a default. And most new features, they actually only support RocksDB. So for example, hot backup, it actually relies on the disk representation of RocksDB. And we started that deprecation in 3.6. And we'll still enforce it further and further also with 3.7. So if you're still running on MMFiles, you should start at least thinking about. I'll finish up a blog post, hopefully this week, which is explaining a bit of the details and also more of the background why we are doing that. We actually believe it's going to lead to better performance and also better feature support. And from a developer perspective, I must say, I also enjoy the fact of just deleting a lot of code lines, making our test setup easier, allowing us to dedicate more test resources for RocksDB, kind of the default use case. Okay, curious, as this is kind of like the call to action for you guys, we're going to release at least monthly alpha builds. So the idea is to do that mid of month, so that should be either end of this week, latest early next week when we release the first alpha build. It's going to have a changelog describing which features are in there, how to test them. And please, if you find something, write an email to the mailing list, contact us on Slack, give us feedback on what you like, what you don't like, what you're missing. And we'll also announce it on the blog, so where you can find the Docker images, where you can find the tarbals and all the other stuff you need to actually run and test it. Second call to action of what is on your roadmap, what are you missing? So if you have something where you feel this should be kind of like on the short-term roadmap for 3.8, for example, this will be mostly features, or also on kind of like the more midterm roadmap on Arango 4.0. I mean, we're around 3.7, 3.8, so it's time to start at least thinking about a 4.0. Either feel free to now write it in the comments, feel free to provide a Q&A, and this will also help us to kind of define that roadmap. So especially if we're talking about 4.0, what I would be curious about is how do you see, for example, APIs? Is there something not just from like a feature perspective you would be looking forward to, but other APIs where you feel, this would be really great if we would change them in this, or is the other way to make it easier to use ArangoDB, because it's a major release and we have somewhat flexibility in what that means on an API level. But as mentioned, this is the kind of midterm future, but already looking for feedback on what might be interesting for you. Otherwise, thank you.